The Ger-
Do you ever have one of those days when you feel as if the roof's fallen in? What can be even worse is not knowing which way is down. How can you tell which way is down? Knowing exactly which way is down is important for builders. Drain pipes, for instance, have to be vertical, that is, straight up and down. To check that a drain pipe is vertical, this builder uses a plumb bob, a piece of string with a weight on the end. The plumb bob is an accurate method of telling which way is down. Down is towards the centre of the earth. It doesn't matter where on earth you are, down is still towards the centre. Even from the South Pole. In fact, that's what we mean by downwards, towards the centre of the earth. We're so used to gravity, we take it for granted. But when astronauts go into space, they find that they can't always decide which way down is. Let's see how confusing life can be when you don't know up from down. First of all, some of them sleep on the walls, and their arms often float at right angles to their bodies. But when they wake up, getting dressed is easy. When you're shaving, you can't put your razor down. And before breakfast, you have to smarten up. Then breakfast is up on the ceiling, that is. As well as ordinary food like bread, they eat curious things like dehydrated strawberries, which have to be mixed with water to make them edible. And carrots. One thing that's obvious is that things don't seem to fall. Nor does this apple. Once you've left the trampoline, you're a bit like an astronaut. You fall at the same speed as the apple, so to you, the apple doesn't seem to be falling. Of course, when you stand on the ground and let go, the apple falls. The story goes that it was a falling apple that gave Isaac Newton a clue as to how gravity works. He was sitting in his garden in Lincolnshire when he was struck by a brilliant idea. He guessed that an apple falls because its mass is pulled down by the mass of the Earth. The force of gravity is a pull towards the centre of the Earth. Remember the trampoline? Things don't always seem to fall. It's just the same in a spacecraft in orbit. They call this zero gravity, but it's really like the trampoline. It's as though everything's falling at the same speed. And that's why a spacecraft is a good place to study the effects of magnetism. Paper planes swoop well, but they soon slow down. Why do you think they don't fly long in zero gravity? We can't get rid of gravity, but we can distort it, twist it, so that up and down get confused. One way of doing this is by spinning. To begin with, the water's surface is level and the candle flames point upwards. What do you think will happen when they're spinning fast? Now the water surface is curved into a deep bowl and all the candle flames are pointing inwards. Can you explain why? Which way is down for the candles? The spinning rides at the fairground are just the same. Some people pay good money to have their gravity distorted. Why do you think this can make you feel dizzy and sick? When a bean germinates, the root turns and grows downwards. How do you think it knows which way is down? And what do you think would happen if you grew beans in a jar and turned it over and over every day while they were starting to grow? Would they get confused? Could you grow a bean with a corkscrew root? When they're in orbit round the Earth, the most extraordinary thing for astronauts is what they call zero gravity and the feeling of weightlessness. This allows them to practice turning in mid-air. That's how cats turn over when they fall, so that they always land on their feet. But this weightless feeling does give them problems when it comes to keeping fit. Taking exercise is difficult, and if they want to go for a walk, they have to be strapped down to give them artificial weight. Down here on Earth, weight is one thing you can't easily get rid of. Weight is a force, the force of gravity, the force of the Earth pulling you down. How do scientists measure weight? Remember, weight is a force, and we measure it with a force meter. Isaac Newton would have been glad to know this apple has a weight of just over 1 Newton. The force of gravity makes things fall. One way to investigate gravity is to drop a variety of things from a great height and watch carefully to see what happens. One question has worried scientists for hundreds of years. If you drop a big thing and a little thing at the same time, will the big one fall faster? What do you think?
The big one's going to fall first.
Well, the big one will fall down quickest. If gravity's pulling it down, it's heavy and it's going to pull it down more, faster.
What do you think now? Do big things fall faster than little ones? Years ago, a Greek scientist called Aristotle was convinced that big things fall more quickly. But he didn't do experiments. In 1590, an Italian scientist thought Aristotle had got it wrong. His name was Galileo, and he did experiments to test his theory. But he got into trouble with the church, who didn't approve of the scientific method. To try and settle the question once and for all, this scientist, Dr. David Jones of Newcastle, is going to drop 2 bricks from the Tyne Bridge. There's a 30-metre drop into the river below. The big one is a 10-kilogram breeze block. The little one is an ordinary 2-kilogram brick. Watch carefully what happens in slow motion. While we're up there, let's look carefully at one brick falling. We've marked the position of the brick every half second during its fall. These arrows show equal intervals of time. What do you notice about how far the brick falls in each half second? How does a spirit level work? It relies on gravity. Gravity is very reliable. Or is it? Yes, of course it is. On Earth, gravity is unavoidable. You can't get away from it. Gravity is always there, whether you like it or not. Gravity can be useful if you get it working for you. It's the force of gravity pulling the water down that pushes the water wheel round. In a water mill, the turning wheel can be connected to all sorts of machinery. In this flour mill, it's used to grind corn. Using gravity like this is easy. It's like canoeing downstream. The force is with you. But if you want to turn round and go the other way, you really have to work hard. Why is weightlifting such hard work? And what other sports make you work against gravity? If you went to the moon for your sports day, which records could you break? On the moon, the force of gravity is much less than it is on the Earth. Can you think why? Remember, the force of gravity is a pull on your mass by the mass of the Earth or the Moon. The mass of the Moon is much less than the mass of the Earth, so the Moon has a smaller gravitational pull. Suppose that gravity could be switched off altogether. What on earth do you think might happen? Can you think how these acrobats are making use of gravity? You can learn a lot about gravity with a bouncing ping-pong ball. The force of gravity pulls it down, and after it bounces, makes it fall again. If we freeze the action, we can see that it travels much more quickly near the bottom of each bounce than it does near the top. Can you explain why? And why do you think it bounces lower and lower each time? Knowing about gravity helps you to avoid some pitfalls. How many examples of the use of gravity in the home can you spot in the final minute of this programme? Gravity wasn't on his side, but may its force be with you.
book to accompany Scientific Eye has been published by Bell and Hyman and is available from your local supplier and most good booksellers.